A thin-walled hollow cylinder has a radius r and a length L. The cylinder lies on the x-axis with the left end at the origin. Find the electric field at location A that is on the x-axis, a distance w from the origin. The ratio of charge on the cylinder to its length is given by U equals Q over L, where Q is the total charge on the cylinder and L is the total length of the cylinder. Now divide the cylinder into smaller rings, each with a thickness of dx. To find the electric field at location A, first find the electric field at location A due to one piece of the cylinder, and then integrate to find the field due to the entire cylinder. Consider a single ring a distance z from location A. The charge on the ring is equal to the product of the charge per unit length of the cylinder and the thickness of the ring dx. The electric field at location A due to the ring is given by 1 over 4 pi epsilon naught times dq times z divided by r squared plus z squared to the 3 halves. Plugging in the equation for dq we found previously, we get 1 over 4 pi epsilon naught times q over L times z over r squared plus z squared to the 3 halves, where r is the radius of the ring and z is the distance from the ring to location A. From the image we can see that the distance z is equal to the distance w minus the distance x. Now we plug in this equation for the distance z into our equation for the electric field of the ring, and we get the electric field of the ring is equal to 1 over 4 pi epsilon naught times q over L times w minus x divided by r squared plus w minus x squared to the 3 halves. Now that we have the electric field due to one ring on the hollow cylinder, we need to integrate that equation in order to find the electric field due to the entire cylinder. We need to integrate with respect to dx. After pulling out all the constants, we get 1 over 4 pi epsilon naught times q over L times the integral from 0 to L of w minus x dx over r squared plus w minus x squared to the 3 halves power. Using an integration table, we get the electric field of the whole cylinder is equal to 1 over 4 pi epsilon naught times q over L times 1 over r squared plus w minus x squared to the 1 half evaluated from 0 to L. And plugging in the endpoints, we get the electric field of the whole cylinder is equal to 1 over 4 pi epsilon naught times q over L times 1 divided by r squared plus w minus L squared to the 1 half minus 1 over r squared plus w minus 0 squared to the 1 half. So the equation for the electric field at location A due to the entire hollow cylinder is given by 1 over 4 pi epsilon naught times q over L times 1 divided by r squared plus w minus L squared to the 1 half power minus 1 over r squared plus w squared to the 1 half.